Hello, and welcome to this presentation on roof-mounted system considerations. My name is Will White. I am an instructor and curriculum developer here at Solar Energy International, and I will be your presenter for this lesson. In this lesson, we are obviously talking about things we need to think about when we are mounting photovoltaic systems on roofs. So we are going to look at the load related to the PV system and the structure and how those two systems interact. We're going to look at the different information that we need to gather to provide to a manufacturer or an engineer when we are designing a racking or mounting system for a specific site. There's different things that we need to provide to be able to ensure that that racking system is appropriate for that situation. We're also going to look at how we calculate the proper size of a lag bolt when we are going to be attaching our racking system to a wood structure. And we'll take a look at some design and installation considerations that we need to think about when we are using a system on a low-sloped, often commonly referred to as a flat roof. And finally, we're going to review everyone's favorite topic, rapid shutdown, and what those requirements are for roof-mounted systems. Now, before we get too far into the lesson, let's go and do a little review from our PV 101 class and talk about the difference in roof type. The two common ways of referring to roofs are steep slope, which is generally seen as a roof with a pitch of 2/12 or 9.5 degrees or more, and a low slope roof, which is generally seen as a roof with a pitch of 2/12 or 9.5 degrees or less. Now, these are not standardized metrics, so the 2/12 is not an industry standard per se. If you look at the OSHA regulations, they consider a steep slope to be 4/12 or greater. Low slope would be less than 4/12. And the National Roofing Contractors Association, NRCA, they define low slope as being less than 3/12. So obviously we can see we've got three different breakpoints between steep slope and low slope. In this lesson, we're going to use the breakpoint of 2/12 because that is what UL has in their standards 1703 and 2703, which our PV racking systems are listed to. So as an industry, that's where we see the breakpoint between what's considered a steep slope and a low slope. Now, I will say with a low slope roof, something that you just want to be aware of so that you can speak knowledgeably and be taken seriously in the industry. There is technically no such thing as a flat roof. Even a roof like we see in the picture in the bottom right, which appears to be flat, does have some slope to it because the precipitation needs to drain off that roof. So if there's no slope, water would just pond on this roof, which is what roofers try to avoid at all costs. So when you're speaking with roofers, never call it a flat roof, always call it a low slope roof. If you use that technique, you'll seem more knowledgeable in the industry and not look like somebody who doesn't know what they're talking about. There are several standards related to engineering, structural engineering specifically when it comes to roof-mounted PV systems. The American Society for Civil Engineers produces ASCE 7, which is the minimum design loads and associated criteria for buildings and other structures, and that includes structures that are attached to buildings like PV systems. So this document has all the procedures for calculating our wind loading, our snow loading, and any seismic loading. It would also have those different wind speed, snow load, and seismic load values for any location within the United States. Outside of the United States, you're going to need to find the specific standard in your country or jurisdiction to identify what these loads are. We need to know the snow, wind, and seismic loads for our location in order to properly engineer our racking system. The American Wood Council also publishes NDS, the National Design Specifications for Wood Construction. This is going to have the tables that we use to determine the pull-out strength for our lag bolts, which is what we're going to use when we do the calculation for sizing lag bolts a little later on in the lesson. So these documents are both things that we may need to refer to occasionally when we're designing systems. To be quite honest, if we're just a designer putting together a system plan, most of this information we may need to provide it, but our racking manufacturer or our design tool is going to do the calculations for us in most cases. So unless you're a professional engineer working in a very specific site that has out of the ordinary requirements, your computer program, whatever software you're using to design your system, or your racking manufacturer is most likely going to do the wind, snow, and seismic loading calculations for you. But we need to be knowledgeable enough to know what information goes into those calculations, how those calculations work, so that we can identify if there are any errors in those calculations before we install the system and run into problems in the future. When we're talking about engineering our systems, there's a couple things that we need to look at. The first one is the racking. Now, this second bullet here, use engineered racking systems from reputable manufacturers. Back in the day when the solar industry was new, the racking systems that were available were somewhat limited, and it wouldn't be unusual to have installers design or build their own racking system out of things like, say, Unistrut. Those days are long gone. We have many, many options for engineered racking systems from reputable manufacturers for all types of buildings, situations, roof types. There's really no reason not to use a properly listed racking system. They're typically going to be listed to UL 2703, which has both structural grounding requirements in that listing. So use a good racking system. Pick one that works for you, both for your location, your environment, the modules that you're using, the type of roof that you're working on. There are options for every roof type. There's really no excuse not to use a proper engineered racking system. The other thing that we need to consider when we're designing and engineering our systems are the building itself. What's the structure of the building like? What type of weight can it withstand? Are we going to need an actual professional structural engineer to design our system and verify that the structure can hold up the weight and the load of that system? I will say that in most commercial applications, if not all commercial applications, we're going to need to get a professional engineer to review that building and the plan to make sure that the building can support the system that we're going to install. Historically, residential systems did not need structural engineering, but that is changing over the last few years. A lot of jurisdictions are requiring not necessarily a stamped plan set for residential designs, but a lot of them are starting to require a letter from a professional engineer saying that the building will support the load of the array. What I recommend doing is developing a relationship with an engineer who can crank these letters out. Usually they're pretty straightforward, a couple $100, and they'll be able to write out a letter for each system that you're designing. You will need to provide them with the appropriate information so that they can verify that that structure can in fact support the load of that system. I'll tell you a story. We had a system in Connecticut that we were proposing for a residential customer. We did do a structural analysis from a professional engineer, not a stamp plan, but a quick overview to see if the building could withstand the weight of the PV system. And it turned out that that structure failed the structural analysis by the engineer. The roof structure needed reinforcement. We proposed a change order to do that reinforcement. The customer did not want to pay the extra for that structural reinforcement, so we did not install that system because the building could not support the load. A couple of years later, there was a serious weather event in Connecticut. It was a snowstorm which was followed by rain, and that building actually, the roof collapsed. So we were right to walk away from that installation. If we had had the PV system on there, I'm sure there would have been some liability there since we were the last ones to touch that roof. So that's the end of part one, our introduction and review of the standards related to roof mounting systems. In the next part, we're going to talk about loading and how adding the additional weight of a PV system to a building will impact the structural loads of that building. So join me for that part when you are ready. Thank you.